equation number 9, you are calculating the standard deviation of a bank. But if you notice equation number 9, it's given in variance terms. So it's the variance of equity equals the asset ratio squared times the variance of the assets plus the liability leverage squared times the variance of the liabilities. Notice what happens. You now have a minus sign in front of the 2. Now, go over to my slide for just a second. It's a mess. It's not pretty. So what I want to try to do is highlight to you the difference between a bank standard deviation and a traditional modern portfolio theory portfolio standard deviation. So if you go to the bottom of the slide, your traditional portfolio standard deviation is the square root to get to standard deviation instead of variance. And if you notice, it's the weight squared times the variance of asset X plus the weight squared and the variance of asset Y plus 2 times the weights of X and Y times the standard deviation of X and Y times the correlation coefficient. When you do all that, you get variance. You take the square root of the variance and you get your standard deviation. You learn that at level 1 quant. But now if you look up on the slide or equation number 9, you see that there is a sign difference in front of the 2. You still have the weights. So for a bank, the weight is the asset leverage ratio. Assets divided by equities, that's your weight. And you square that. And then you have the variance of the assets. Plus the leverage, which is the asset ratio minus 1 squared. That's your liabilities, that's your weight, times the variance of the liability. Notice now it is a subtraction instead of an addition. And what this subtraction does is if you look to the right side of the equation, you still have the weights, asset leverage, liability leverage, times the standard deviation of the assets and the standard deviation of liabilities. But that correlation coefficient, you want it to be as high as possible. Remember, that's the delta I divided by the delta Y. It is that systematic benchmark risk that you want, that when interest rates change for a bank, you want its liabilities and its assets to move in a tandem fashion. Therefore, as in Exhibit 24 and Exhibit 25, the correlation is 0.85. The higher the correlation, the less the magnification of interest rate changes between the effect on the assets and the liabilities. So how do you minimize the magnifying glass from burning up the bank? You bring the asset durations down and the liability durations up. You bring the dollar durations down and the dollar durations up, and you get that correlation coefficient as high as possible. Those are your mechanisms to balance out the bank's risk. Because if you look at the equation number 9, if I can get the correlation close to 1, then I subtract that last part, the minus 2 times the asset, the liabilities, the correlation, and the standard deviations. All of that gets subtracted from the risk of the bank. The front part of the equation is the weighted average. Here's my assets, here's my liabilities, here's the variance of the assets, here's the variance of the liabilities, here's the weighted average between the two. But in equation 9, we subtract that when there's a high correlation, because that means we've reduced the risk in the bank. That when interest rates change on the liabilities, then they change on the assets in a similar fashion, and we don't have the magnifying effect to burn up the equity in the bank. And if you don't recognize that equation 9 is subtly different than the portfolio standard deviation with a +2, you're going to screw it all up. You're like, oh, this is an errata. No. Now, this is then where I'm going to change paths from what I've done before in the past. Now, watch this. Now, if we go back to derivatives, you got options, futures and swaps, foreign currency risk management. And in foreign currency risk management, in section 2, we talk about creating a variance of a portfolio that has a foreign asset and a foreign currency. And remember, when we did this, it was equation number 5. Equation number 1 was the returns, 1 plus the return of the asset, 1 plus the return of the currency, minus 1, and we got the return of the portfolio. This is the variance of that portfolio. So I've got the variance of the foreign asset plus the variance of the foreign currency plus 2 times the standard deviations of the asset and the currency and the correlation coefficient. And we know that interest rates and bonds tend to be related, so therefore higher correlation, but interest rates which affect currencies and equities tend to be lower. So a foreign portfolio of a foreign stock and a currency is going to have less risk than a portfolio of a foreign bond and its currency. But we noticed in equation 5, there was a subtlety. And that subtlety says, notice the weights are missing. So if I go back 1 slide, notice a modern portfolio theory equation at the bottom of the slide. I have weights. The weight squared times the variance of x, the weight squared of y times the variance of y. In equation 5 in currency risk management, the weights are gone because it assumes that I own 1 foreign asset, 1 foreign currency. So the weights are gone. So the ones would be there, but they're missing. Now you probably remember that. But now here comes the kick in the teeth. I'm like Chuck Norris. I'm on my toes and I'm swinging and you don't even know it's coming around the roundabout and I'm going to knock your teeth out. Because blue box number 7 at the end of the currency risk management reading has another standard deviation equation. And if you notice at the bottom of my slide, it becomes a -2, not a +2. And you're like, WTH, what's going on there? So if you recall, when I buy a foreign asset, it's because I love the stock. Novartis. Well, how do I buy Novartis? It's a Swiss stock. I got to take my US dollar and go to the Cook exchange desk at the airport and get Swiss francs. So now I got a Swiss franc and I'm going to go buy Novartis. So I got a Swiss stock and I got the Swiss foreign currency. You like the Swiss stock because of the demographic play on diabetes, but you don't like the Swiss franc because there's lots of inflation going on in Switzerland. So you want to hedge out of your Swiss franc. How do you do that? You short a forward contract on the Swiss franc. And when you short a forward contract, what is the weight? Negative. And because the weights are 1s, a +1 for the Novartis and a +1 for the Swiss franc, but now you've shorted a forward contract, that +1 becomes a -1. So a +1 on the asset times a -1 on the shorted forward contract on the Swiss franc gives me a -2 to calculate the 2 asset class standard deviation in blue box 7 in the currency risk management reading. Now, all of you look at Christian for a moment. He looks like you could just pull the coffin closed on him right now because he's like, I don't know, Mark, you just totally demolished me with those 4 equations. Pretty much. So I put these 4 together for you because if you can get your head wrapped around this, it's not a memorization process. It is an understanding process. So when Harry Markowitz in portfolio selection in 1956 at the University of Chicago came up with the 2 asset class standard deviation, he basically said when you mix 2 assets that have low correlations, it diminishes the portfolio risk. It is the free lunch of Wall Street, to borrow from Peter Lynch and Burton Malkiel, random walk down Wall Street. But when we deal with a bank, we want a high correlation between the one systematic risk factor that impacts a bank's assets and a bank's liabilities, interest rates. Because when we have a higher correlation, it reduces the risk in that case. When we have currency risk management and we're calculating the standard deviation of that two asset class portfolio, the foreign asset and the foreign currency, the weights are 1, so the weights drop out. Then if we shorted the currency because we fundamentally either didn't like the fundamentals, the carry trade didn't look appropriate, there was too much volatility, or there was something going on with the support or resistance level within the security, so we wanted to short a forward contract on the currency. Now my weight goes from a +1 to a -1 and changes again the two asset class standard deviation for a foreign currency portfolio.